Hi everyone, welcome back. If you are a regular viewer of my channel, if you're a subscriber, you know that we focus on Python code to address image processing primarily, but also any type of data analysis. Now in this video, I am going to not do any of that because this is about just providing a holistic view of what software languages are out there and what is appropriate for you based on your specific interests. Again, if you're not a subscriber, this would be a great time to pause the video, hit the subscribe button, and while you're there, you see the little thanks button. That's, if you're feeling extra generous, go ahead and click on that. Now, I am not going to tell you what is good for you, what to learn, and all that, because that depends on your specific type of work that you are interested in. Like if you're an early coder, you're probably thinking about, okay, how should I structure my learning? Should I start with Python? Should I do C++? Or no one can answer that question other than yourself. Basically, you have to think about what your career path is. Where do you want to get to? Are you going to be a researcher and using coding as a means to automate things like extracting insights from data, in which case you can completely ignore 99.9% of the languages that are out there and focus on like Python and R, and you are probably okay. But if you want to work for a company or start your own company that actually does some sort of a product, right? You're trying to generate a product, and let's say a hardware product. You want to create a AI powered drone that can go and look at a whole bunch of your farms and then come back with information about, hey, you need to go to this location because you're not getting enough water around there or something. I'm just making up something hypothetical here. But if you're planning on doing something of that sort, then just learning Python is not enough. Yeah, Python is good enough to process your images, but you need a few other things to actually put this product together. So the next 20 minutes, 30 minutes, I don't know how long this is going to be, but this video is all about just running through a few scenarios. Hey, if you want to develop desktop software, these are the top choices that you have. And at the end of this video, let's actually go through a hypothetical situation where let's take the drone example. And if you want to build that product, like what is the learning path? What should you learn first, and then second, and then third, and so on. So you get a good holistic view of what's out there, what type of software is out there, and how you can learn some of it. No one is good at all of this, but of course you need to be good at some aspects depending on where you want to get to. Okay, that's a long introduction, but I hope you understand the reason why we are doing this, or I'm doing this tutorial. And if that matches your interest right now, hopefully you'll proceed and watch this video in its entirety. Now, first thing first, why software? Because it's very important. I don't think I need to convince you in 2023 why you need to give importance to software, but it powers our applications, right? So it doesn't matter. It's your iPhones, for example, from Netflix to microscopes. It doesn't matter. Even microwave, not just microscope. When you punch a pre-programmed button, something is happening in the back end, right? So there is software everywhere. That's why it's very important, but the right software must be picked for the right job. This is very important. You cannot just learn Python, like I said, and then try to deploy like super fast reactive software that you need for a specific type of job. Then you need a different type of software stack for that. Now let's take this microscope example, right? So what do you have on a microscope? You have an automated stage if you have an automated microscope where the stage moves and you image it. And this can be a telescope. This can be any instrument, okay? It doesn't matter. There is something that's moving in this example. And why? How can it move? Because it has a motor. As you can see on the bottom left-hand side here, there is a motor, and these motors typically have some sort of an interface, right? So in this example, I'm showing you RS-232, but that interface can be an Ethernet port or a USB port. It doesn't matter. You plug it to something so you can send commands through that interface so the motor does what you want it to do. Now, how do you communicate? So, well, the manufacturers, typically they provide the software development kit around their hardware or an API so you can interact with this piece of hardware. Now, and these APIs, by the way, and SDKs, they are often written in C, C++, or C Sharp, and most of these DLLs that actually are used in this type of, to recognize, to communicate with this hardware, they're all written in this C, C++, C Sharp for legacy purposes. So it does help for you to learn these languages, definitely C++, if you want the finer control, right, of your hardware. So that's one takeaway right away. Now, you can use this API that the manufacturer provides to write a program in C Sharp or C++, and you can send an appropriate command to the motor controller. And the API call can be as simple as, hey, move stage to position X and Y. And then it moves it to that specific position, right? So then your motor X turns, motor Y turns accordingly, and then you get the stage to that right position. And of course, to control this hardware, C, C++ is probably a better choice compared to Python. You can also use Python to communicate, but C, C++ are these faster packages because they're compiled. They are not scripting. They're not going through your script to execute. So they're usually faster. And for hardware, you want movements to be real time. You want the movements to be pretty fast. So that's why C, C++ can be a good choice. So this is just a overview of, just a quick introduction, right? So why software and why C++ in this specific example. Now, the world of software is pretty vast. I mean, you look at programming languages, some I have never ever heard. Some are completely gone. Like I learned Fortran back in 1990s when I was doing my master's in physics, and then started my PhD in material sciences in 1997. And then I had to switch my mindset from Fortran to something else. And things constantly change, right? I mean, I had MATLAB at some point and a whole bunch of different languages. So languages always evolve. But once you have a mindset of coding in one language, usually the skills are transferable to other languages. So today our aim is to provide this clarity in terms of why certain tools are chosen over others. And let's go ahead and jump in. Because we talked about hardware, let's go ahead and start with hardware. So if you want to work on projects where hardware interfacing is important, and this often happens even in academia. So C, C++, I already mentioned, they offer low-level access. So my recording screen is in the middle, so let me move that away. So they offer low-level access because you can, now if you need very fine-grained control of the hardware, then C, C++ can be very useful for you. And we already mentioned why. I mean, it's a compiled language, so it's much faster, and most of the drivers are written in C, C++ anyway, so it makes it faster for communication. Now, moving ahead, if you look at Python, again, I don't have to give reasons, at least to my regular audience, on why learn Python, because that's all this channel is about. It's super versatile. It's got so much community that's actually supporting it, and it can do all kinds of jobs, from data analysis to even interacting with hardware in this case. And you have libraries like PySerial, for example, for communication. So Python can be used for hardware interfacing, but if you really want to deploy a product using one of these coding, then C, C++ is probably your best bet. Now, LabVIEW is another piece of software that you probably hear about if you're in academia. If you're a PhD or postdoc or a researcher, you may have worked with LabVIEW in the past, right? I mean, we always have to work with some sort of a software, some sort of a hardware where it doesn't come with like real software, or you're repurposing that hardware for some other task. So either way, it comes with a bunch of DLLs, and you acquire DLLs from somewhere, then and you communicate with it via LabVIEW. So these are some of the choices. Again, there are a lot more out there. You can go very fancy and find exotic pieces of coding languages, but these are the ones that I think are the most common. If you learn Python and C, C++, you're good when it comes to hardware interfacing. Now, for research and analysis, again, of course, Python is number one for research and analysis with libraries like NumPy, SciPy, Pandas, and for plotting Seaborn and Matplotlib. Python provides you the right ecosystem for analysis. Now, when it comes to statistical analysis, of course, Python has a lot of packages for statistical analysis, but R is a very well-known programming language for statistical analysis, because it again gives you a nice ecosystem for data analysis and visualization purposes. MATLAB, I've already mentioned about MATLAB. I've used it briefly a couple of decades ago when I was still in academia. But when I come to industry, the licenses for MATLAB become very expensive. So you often see people in industry working with Python instead of MATLAB, even though they probably came from a lot of MATLAB experience back in academia. This is unfortunate because I really like MATLAB. It provides excellent simulation capabilities and also, of course, a lot of toolboxes, including AI toolbox or machine learning toolbox. I forgot what I don't even know what they call it now, but it's probably called one of those, machine learning or deep learning or AI toolbox. So MATLAB can be useful, especially if you're in academia where you can get your hands on MATLAB without paying a lot from your pocket. Then that's not a bad choice. Okay, now moving on to actually desktop products. Now you're actually trying to create a desktop software product so others can use it on a desktop. Now, C++ is by default, I would say, a powerhouse because it's very performance driven. So you can create these applications, very strong applications using C++. And of course, if that desktop needs to be interfaced with a hardware, C++ is a no-brainer choice in that case. Java, if you don't want to be only Windows focused or Mac focused or Linux focused, whatever, then Java is a platform independent software, so it is definitely a popular choice. So Java, again, if you're starting off, then Python, C++, Java. These are the top three in my mind. C#, again, it's integrated with the .NET framework. So if you're trying to develop any Windows-based applications, then C# can be very useful. Python also for desktop software applications, especially if the application is small, right? So you're trying to create a small widget that does something, then PyQt, tkinter, and Python can be very useful for an application that, where inputs are provided via a GUI. So now moving on to web development, right? So now more and more products are web-based products and they are in the cloud. So what is used? So whenever we talk about web development, there are two things. There is a front end where the user interacts with, and there's a back end where most of the computation or databasing or whatever happens in the back end. That's something that the user does not need to see, or in some cases should not be seeing, because you have some private information about other users and all that, right? So you always have a front end and a back end. And in the front end, of course, HTML is the main thing. In fact, I remember back in 1997, 98, I was actually writing HTML code by hand. It sounds cool, but it's extremely simple language. So I was creating these web pages. I was a grad student, and I was doing my PhD, so I had like my own student web page. It was kind of fun, scanning my pictures and then kind of uploading and all that stuff. Now, as time went by, like in late 1990s, I think a product called Dreamweaver showed up. So you don't need to do anything. You just need to put up a design, and then it creates the HTML in the backend. So most of these languages probably will be automated as time goes by, because ChatGPTs and others, they can actually create this code. But that doesn't mean your jobs will be gone, because if Dreamweaver can actually do HTML and with all the Flash and everything, you can do JavaScript automatically generated, then you would think that all these front-end developer jobs will be gone. But no, we need more front-end developers now than ever before. So the jobs will not be gone. It's just that the nature of what you do slightly changes. Now you're using these automated tools as your assistants, and then you get more productive. That's just my honest view. I just realized I was just going on a tangent where the focus is on what software, but I went on a philosophical rant about how automation can be useful. Okay, let's back focus. So front-end HTML is used for structuring your content. Where does the text where is your image, where is your other elements of the web page, gets shown. But CSS actually styles it, right? Like what type of style do you want to apply, what type of design do you want to apply. So that's all CSS. And JavaScript actually makes these web pages interactive, because nowadays these web pages are not static anymore. They're supposed to be interactive, so JavaScript actually allows that. Now, how do you develop this? There are frameworks, like two primary frameworks are React and Angular. I believe React is originally by Facebook, and Angular is by Google. I'm not sure, but that doesn't matter. React and Angular, they kind of enhance the JavaScript's capabilities, so they can be good frameworks for you to work with in developing the front end. Now, you have a whole lot of backend, right? So the front end actually takes the inputs from the user and stuff happens in the backend. And this is where a lot of technology resides. So we typically call the backend server side, where the data processing actually occurs, right? So when you use the front end on Google, you're typing what you want, but that information gets distributed to a whole bunch of servers in the back end, and the processing actually occurs. So what languages are used? Of course, Python you can use with frameworks like Django. Again, these are all the terms I'm throwing out. So once you figure out, okay, this is what I want to do, you obviously need to go in and do a lot more research into what these are and how to learn those. And Node.js actually gives access to the JavaScript on the server side. Remember, JavaScript, we actually placed it in the front end part, because that's where most of the action happens when it comes to JavaScript. But of course, if you want to allow it on the server side, then Node.js is one of the key pieces of technology, I should say. Now, app development, right? So now we talked about previously web development, but now actual app development on your phones and other devices. So what languages do you need? Now let's focus on two primary things. First of all, Android. Java has been traditionally used for a long time to develop apps on Android, but Kotlin is the latest one that's actually provides you easier syntax and makes this app development accessible to not super advanced coders, but even someone coding in Python. You should be able to learn how to do these things. Same with iOS. Objective-C was the original language, but Swift, I think, is the one that's being increasingly used to develop these iOS apps. But more and more apps are platform independent, right? So you have the same app, whether it is Amazon app, right? So you can use it on Android, you can use it on iOS. Now, it's not like they are developing these two using two different frameworks, you want exactly the same framework, but deploy it in both. That's exactly where cross-platform apps, actually cross-platform frameworks like React Native is an amazing tool for this cross-platform. I kind of dabbled into this app. I don't even want to mention the app that I developed along with one of my coding friend, but we did that. And why did I do that? It taught me a lot of lessons, how to do it, what is the process. Everyone should do that. On Android, you can just push and publish. I'm not sure. I think you can still do that. And on iOS, you need to wait certain time, for them to approve. Obviously, they don't want all kinds of crap on their platform and decrease the quality. They have a lot of checks for quality and security. So either way, again, let me bring the discussion back to what we're supposed to talk here. React Native is one of those, and there are more and more languages and frameworks that you see for this cross-platform application development, and most of those will let you automate. Basically, you design what you want and you place elements and tell me what you want, right? So most of the code is automatically generated, and you need to go ahead and make sure that the appropriate databases are in the back end, and how to connect the front end to the back end and all that stuff. So now, talking about databases. So databases in software development, there are many databases. Again, it depends on what you want to do. And if you want to learn, get your feet wet with database, SQLite is the one that I definitely recommend, because it's obviously, as the name suggests, it's light. Like SQL is traditionally the the well-known relational database that existed for multiple decades. And SQLite, think of it as a lightweight version of it, and it's a file-based database. And of course, it's ideal for local storage in desktop and especially for mobile apps, because you cannot deploy a humongous database onto a mobile app. You need a lightweight version, and SQLite can provide that. And web backend, like if you have a strong application and you need a web backend database, then PostgreSQL, MySQL, these are the relational databases. And if you don't like SQL, or for whatever reason you don't want to use you want to use a NoSQL based database, then MongoDB is quite famous, I should say, because it provides the flexibility. Why do you not want to use SQL? Sometimes for certain applications, you may find it to be a bit restrictive, but MongoDB is the answer if you run into that. But again, if you learn one of these, all the others are very intuitive. It's the mindset that you need to get into. And for that, don't start with the most difficult one, start with the easy one, which is SQLite. Same with coding, right? I mean, if you get into Python, you develop the mindset of how to think to write the best code, and then the syntax can be different for C++, but at least you know how the logic actually works. Now, app development, of course, what database is SQLite? Like I already mentioned, because it's very lightweight for apps on mobile devices. Okay, now we cannot just not talk about big data, because even though you may be working with small data, I don't know, big data is something that you will run into as your company grows, as your startup grows, or whatever, as your project grows, right? You'll eventually find yourself in a situation to handle and work with large data. And it's not just about volume. It's not about, oh, I have 2 terabytes of data set, so I am big data. Of course, that is big data, but it's also about handling the data that is vast. It's not one file that's 2 terabytes, but you have lots of data that comes in rapidly towards you. Now, what do you do? This is where I think for most of us, the knowledge, we hit a wall. I'm like, okay, now what do I do? And of course, you need to consider the storage. But again, how do you process? How do you warehouse that? And how do you create workflows out of that? Because you don't want to do manual steps. You want to create some sort of an automatic workflow. And not just that, you need to be querying big data. You have all this data. You need to ask questions about, hey, can you give me this? Can you give me that? Find this information. So querying big data. So what tools do you have? Very similar to the others, but again, first thing, let's start with, these are new terms that you probably hear quite a bit when you read online blogs and start watching YouTube videos, and YouTube may be recommending some videos that with these keywords like Hadoop, right? So HDFS is part of this Hadoop ecosystem, and it distributes this data across many machines. And many different people are different organizations, different frameworks. They have different ways of handling big data and working with big data. And again, typically it involves distributing the data across many machines. Like for example, Google, when you search for, I don't know, how to, whatever, search for a recipe, right? So it's not like it's looking at one server. It's actually distributing this across many servers, because the data is distributed across many servers, and it's fetching information from these, and then it's putting it together. That's why it's so much faster, right? I mean, compared to you searching your local Windows and then trying to find, okay, I want to find this file. Okay, let's get back here. So that's a HDFS and NoSQL database. For example, you can use Cassandra, which is known for its scalability. Again, I on some of these topics, I pretend like I know something. I don't know anything about Cassandra. I researched it, and I actually got like, okay, this is the statement that summarizes it, and this is the core benefit, and that's what you're seeing on the screen. Okay, so I'm no way qualified to talk you about Cassandra, teach you about Cassandra, because I have no knowledge. But I know that if I am looking for a NoSQL database and I have big data and I need to explore something, I know that I need to explore this. And I have Python skills, and I have a little bit of C++ skills, and I have some other skills, let's say front-end development and a little of back-end. I'm like, okay, now I need Cassandra, right? So I'm looking at the gaps in my knowledge, and I'll fill that here. So again, HBase has a tight integration with Hadoop. If you are working with Hadoop ecosystem for your big data, then MongoDB, again, as we talked about, it also offers flexible document store. Now, these are the databases. No SQL database. Of course, you can always use SQL databases for big data. Now, how do you process it? Okay, now you have data handling, and how do you process this big data? So this is where these terms the term Apache will come up. So Apache Hadoop, of course, it uses a technique called MapReduce to process this data in parallel across these distributed clusters. So it's not as fast, but it is fast enough where it's actually processing this data in parallel. Now, if you want really a faster one, then Apache Spark, it's an in-memory processing, so it can be much faster than the MapReduce method. So Apache Spark, again, if it can do batch processing, stream processing, and so on for parallel processing applications. Now, another thing, Apache Flink. It's again, stream processing framework, and Apache Kafka is a distributed stream platform. If you don't know what I'm talking about, don't worry. You will find, if you find yourself in a situation where you need to process big data, then you'll probably run into one of these, and you can, of course, go ahead and search and learn more about this. And one thing you should notice, I'm not only talking about coding languages, because Python, C++, C#, they're all coding languages. And now I started talking about the frameworks that allow you to perform certain tasks like big data processing, the framework, Apache Flink, and Kafka. Now, if you are, obviously you need to process, but now you need to analyze, like data analysis, and you need to warehouse this data, right? You can't just store them in active storage all the time. So what do you need for that? Again, if you want to do machine learning tasks on this big data, then MLlib, again, this is part of Spark's machine learning library, and it is supposed to be scalable machine learning. It's supposed to offer you easy to use scalable machine learning algorithms. And Mahout is another term that you often hear, at least that gets shown to me on YouTube all the time, maybe because I try to research areas in this with these keywords. And it provides you with you can call clustering as machine learning, but again, with clustering, classification, and a whole bunch of other tools for data analysis. Now, if you want to warehouse your data, then again, I'm throwing you a few of these: Redshift, BigQuery, Snowflake. Snowflake, I literally live within a mile from one of the big Snowflake buildings, and I passed through that like 1 year, and I'm like, okay, I need to look at what these guys actually do. I'm pleasantly surprised to learn that they are this cloud-based solutions for this data for your big data warehousing. Okay, so this is big data. Now, how do you query big data? You warehouse, you store it, you process it, but you need to query it, right? You need to get answers, you need to get information. So this is where Apache Airflow, again, Apache dominates this entire big data realm. So you probably can find solutions within their ecosystem for the task that you're looking for. So Airflow is a tool to define, schedule, monitor any of these workflows. And there are others. Did I include that? We'll see in that second. But Apache NiFi automates the flow between systems. And again, it's more of a visual interface. So it's not a coding language, but it allows you these tools that you connect and you can join them, and you create a workflow. So that can be very useful for if you really don't want to get into creating the workflows, stitching the workflows using your own custom code. And Apache Hive is a SQL type interface. So again, it's low code to easy to no code to query this data stored in Hadoop. Right? So you can easily use SQL type of commands to actually get this, to retrieve this. So if you're looking for languages, then if you learn like SQL, like using SQLite, right? If you can learn the basic commands like how to get information and so on, then that knowledge is transferable to Apache Hive and any other databases. that you work with. And if you don't want to work with this Apache, if you are looking for third party, well, why would you do that? You try to stay in their ecosystem if you are using multiple of their products, but there's always a reason why you want to use someone else like Presto. It's again not just Apache. If you work with Amazon AWS S3, MySQL, MongoDB, whatever, then this can be a good querying software, let's say. Okay, so now I gave you a whole bunch of stuff, a whole bunch of information about different things. Believe me, there are a million more things that I'm not even including here, but this kind of summarizes exactly what is out there. Now, the question is, okay, all that is great. Now, where do you get started? This is why I kind of created some, let's say, walkthrough of hypothetical products. So learning plan example, let's go through this. A smart drone, an example I mentioned to you earlier. What does that do? So you launch your startup, or you work with in a startup that's focused on developing a drone that's equipped with multiple sensors. And what do these sensors do? They collect all kinds of information. If it's an optical camera, then it collects a whole bunch of video feed or photos. If it's some sort of infrared sensors, you get lots of data, whether in the form of images or some other type of data. So all this data need to be processed, right? So why do you use this data? Well, let's say the functionality relies on computer vision and data analysis to identify, for example, unusual traffic patterns. Okay, so I just made this up. It can be anything, but let's say that's the goal. Now, in this scenario, how do you structure your learning path? I mean, I say startup because in startup, you tend to do multiple things. You cannot hire a front-end developer, a back-end developer, a database expert, a integration specialist, and integration and testing person. You cannot hire an algorithm person, a machine learning person. You are all of that initially. Or even if you start working for an early stage startup, you may have 2 roles or three people doing this entire technology side, and you may find yourself in a situation where you should understand a whole bunch of different technology stacks. You may not be the expert. You can outsource some of that, but you need to understand what does it take, right? So if that is the case, what type of languages and skills are involved? So that's basically the walkthrough for this next exercise. So learning plan example right here. So you start with Python. So if I were the person doing this, I always start with Python because I know that that's where I can get started with coding. Like I want to learn the fundamentals. I want to explore some of the libraries like NumPy and Pandas because I know eventually I want to use algorithms that are deployed via Python. So I'll start with Python basics. I'm assuming you know nothing. Okay, you're starting off with Python, and Python is easy to learn. If you spend 1 or 2 hours per day, within a month you see significant difference in your capabilities of coding. And another point I want to make: do not code anything from scratch when you're doing anything. Go look for open source code that you can actually reuse for your own specific purposes. I see people on social media, sometimes even for my own videos, like comments and all that kind of stuff. They're like, "Oh, you got this code from here," and you're kind of, yes, of course. I'm not shameful that I got something. I'm giving you a reference that I got the code from somewhere. Why do I reinvent something that someone else already did? I want to use it to solve my problem, which is, I don't know, detecting cancer cells or something. I don't want to waste my valuable time redoing the code that others have already perfected and published a paper on it or put it on GitHub, right? So don't be ashamed of taking the code that's out there, but obviously give the honor the licenses that they have. So if it comes with any license that requires you to put their name, you have to follow that. You cannot just not do it, especially if you plan on starting your own company. You cannot fall into legal trouble, right? But ethically also, it is the right thing to do. But don't write anything from scratch. In fact, for God's sake, use ChatGPT to give you the code. It never works. I tried ChatGPT. It never, ever works. But you take it and you modify it and then customize it, right? So Let's continue the journey here. Now, computer vision with Python. Now that you are done with fundamentals, now you need to learn about computer vision because that is the application you have. If your application is forecasting financial in a stock market or something, obviously you need to look at these financial packages and time series, how to do forecasting, that type of stuff. But in this specific example, you're looking at computer vision for Python and learn this OpenCV, like computer vision concepts. And OpenCV is a great library to get started with computer vision. And of course, once you're done with that, you can look at advanced techniques like motion detection and optical flow. All of these can be available using non-machine learning approaches like using computer vision. Again, OpenCV is one of the key libraries if you're getting into this computer vision. Now, of course, you're collecting all the data. You need to store it somewhere. So you need to learn about data storage with SQLite. Well, with any database, MongoDB is also okay, but SQLite it's a good one to get started with. So how to store, manage data using SQL and practice the queries, like how to get data, how to retrieve the data, how to manipulate the data, and so on. Now, data analysis with Python. Now you continue the Python journey, and now that you understand the basics of computer vision and understand the basics of data retrieval and manipulation, now you need to develop your machine learning skills. And traditional machine learning includes scikit-learn, TensorFlow. Scikit-learn, but if you're getting into deep learning, then you pick one of the two, TensorFlow or Torch. My recommendation is PyTorch because that is the one that's actually, winning between the two frameworks, between TensorFlow and PyTorch. Although I should admit, TensorFlow is easier to work with, especially via Keras interface. And apply this machine learning to your sensor data to make sure that you're getting what you expect to get. And this is, again, you're in a proof of concept, right, stage where you're trying to make sure you have the right algorithms to actually infer the right type of information that's actually from the data that you're collecting. Okay, now let's move ahead. And now you have to start thinking about integrating your sensors. How do you integrate your sensors? Like start working with accelerometers if you have that in your drone, like gyroscopes and GPS and cameras. Like you have all this data, like how do you handle this data, and how to read basically and process this data using Python. Again, we're still sticking with Python, right? So Python can actually get you a long way. And now you need to focus on real-time data processing. So processing data that has already been collected is one thing, but processing data that's actually streaming is another thing. And if your application requires that, then of course, this is exactly why we talked about big data earlier. This is where Apache Kafka or Apache Flint can be very useful for you, where you can experiment with, this real-time data. And once you master that, then, now I need to think about advanced databases because SQL is probably not enough. You may have to use something that's more robust, like PostgreSQL, or learn about the cloud-based solutions. For example, you're streaming data to the cloud, then you have Amazon RDS or Google Cloud. You pick the cloud. They all have database solutions. And of course, the main advantage there is they're all scalable. And now finally, this is all the backend. Now you want an app, right? So you want the person interacting with this, interacting via some sort of an interface. Let's say that is an app on a device. It can be a Windows app, it can be iOS app or Android app. It doesn't matter. Now you need to develop an app. So you need to think of UI. Again, you are the UI UX expert right now. And you need to understand the concepts of UI in general. And you need to use the appropriate framework. Again, I mentioned about this earlier. It can be React Native if you're developing this cross-platform application apps, or you can use Swift for iOS, as I mentioned earlier. Okay, so now you are learning about app development, and the next thing is, do you really want any finer control over your drone? And that cannot be done via like the straightforward API. You need to perform like a bit more advanced manipulations or something. This is when you explore C++. In this specific scenario that I'm mentioning here, C++ is definitely optional, But if you are controlling a microscope, or if you're controlling an MRI machine, or something, where the hardware is connected to your microscope, then C++ can become even like a lot more important, even more important than Python, right? So in this example, it's optional. And of course, finally, all of these elements should come together, which means you need to understand how to integrate all these components into a single ecosystem or cohesive system that actually works together. And of course, you have to test your application for both functionality and safety. These are very important before you actually before you go to the market, right? So these are very important. And of course, you need to learn about privacy. And did I put FAA here, or is that the next, probably the next one? Or even in ethical considerations right here, right? So you need to get, if you plan on operating drone, then you need to get, for example, you need to understand what FAA rules are, because you cannot just fly anything in the air. You need to understand what the limitations are and what can be done, what cannot be done. And at this point, of course, my personal experience, you can try to teach yourself a lot of technology. That's not a big deal. I think most of my viewers are probably like me. You can teach yourself Python, maybe C++, and how to develop these front-end apps and all that kind of stuff. But when it comes to two things, one is business, like how to start a business. What for example, you want to hire your first employee, right? So how much percentage of this business do you want to give to that employee, right? I mean, do you have any experience? If not, you need some external advisors. Now you need to hire someone who knows what starting a business is. So that's one thing that's not really easy to learn, especially for your first business. And the other thing is legal stuff. So what are the legal implications? If in this case, FAA rules, you need to understand if you're handling a lot of data, what are the data privacy? If you're operating in Europe, it's different compared to in the US, compared to in India or other countries. So you need to understand the data privacy laws for that specific region, even to train your own machine learning models, right? So when you download some model, when you scrape internet for to download certain images, when you train a model, is that model legally, can you actually train a model and deploy it into products? The rules are all over the place, and you need an expert who can provide you the right information. But ethics itself comes from inside. You need to have the right heart to make sure that you're not abusing the data that you're collecting, especially in this scenario, because you are collecting a lot of data from public scenes. Okay, finally, deploying and monitoring. Obviously, you're going to deploy your system, and you need to continuously monitor, evaluate the performance in real life scenarios. In lab environment, in your test environment, that's a different thing, but in real life scenarios. Autonomous driving is fine if you have close course, or if you have like some obstacles that are artificially put to test your car. But once the car is on the road, then it's a completely different scenario, right? I mean, I'm even thinking about, not even in countries like India, because in India it's a nightmare. You need sixth sense to drive. But even in the US, it's not, or in the Western countries where you think traffic can be organized, not in the cities, right? I mean, you have a lot of uncertainty. So testing this in real life scenarios is very important, or learning from real life scenarios is very important. Now, so this is for this hypothetical scenario. Now, in addition to the above, there is a lot of stuff that you need to learn, especially version control. Like if it involves like any FDA or FAA or any organization's approval, then traceability is very important. Tracking is very important. You need to know what version you are deploying in what version of your final product. Who did what? In some cases, like for example, FDA, it can be very important to track like who did what experiment, when was that run, and that kind of stuff. So learn about version control for software for sure, and different IDEs. For Python, it's a bit straightforward, but different frameworks that we talked about, they offer different types of IDEs. You need to learn about it, and you need to learn about network, for example, networking. How do you network your device with others? So Wireshark is, for example, a good example there. And obviously, you need to test and debug your code. So that is what framework are you using for testing and debugging your code? And continuous integration, continuous deployment is a must for modern products. So Jenkins can actually help you, and others like Travis continuous integration like Travis CI, and GitHub Actions can also be used for the CI/CD applications or tasks, and simulators, right? I mean, you cannot always deploy a drone and then try to test your software. Like when you're writing software, you cannot just deploy the drone and then test it. You may not have a hardware. You need to have a simulator so you can actually test it and see if it's working. And then, of course, final test, you always do it on a real hardware. So you need to have some simulators, and regulatory knowledge I already mentioned about FAA. And of course, you need to learn about project management, and you need to practice project management. For that, Trello, Asana, there are many tools. Like Microsoft also has like a lot of products if you are working with Microsoft ecosystem. But and a general knowledge of microservices architecture, because you don't want to create a code that's a monolith. You have multiple microservices that are talking to each other. So even if one goes down, it's not a catastrophic failure. You still have something that's actually running, and that one thing can be fixed and can be deployed right away, right? So this is all microservices architecture knowledge. I think this is a long video. I didn't expect this to be this long. I thought I can speak through this in 20 minutes or so, but I really hope you found this to be insightful and useful, especially for those who are getting started. You're thinking about starting your own startup, or you're thinking about joining a startup. Hopefully some of this information can be useful for you. Okay, after this long video, again, I'll try to do some of these tips and tricks types of videos occasionally, but my primary focus is always giving you Python code at the end of my tutorial, which means we are solving a real problem using Python code. And if that interests you, and if you haven't subscribed to my channel already, this would be, again, another good time to do that. Thank you, guys.